because these are the things I've already, even some of them I've already talked about. Hmm? Hmm. So we are looking at composition and resolution of vectors. Hmm. So which means when we are talking about vectors, we must know, and when we talk of vectors, we are not just meaning vector in biology, we are referring to vector quantities in physics. Okay? We are referring to vector quantities in physics. So if you can recall, I remember when we were looking at dimensions, we define all these kind of things where we are talking about the quantities, the physical quantities. In physics, we look at physical because physics means nature. Physics is coming from two Greek words, which means what? Nature. In Greek, it means nature. So which means when we are talking about nature, these are the things which are what? They are visible, they are tangible. Which means we look at things which are measurable. Which are what?
Measurable.
Measurable. So, and in physics, we refer to them as physical quantities. And we talk, and physical quantities, again, they're divided in two categories. The fundamental quantities, which we call them the basic. In mechanics, we refer to them as fundamental, and they're only 3D. They're only what? Only 3D. That is mass, time, and length. But when we talk of basic quantities, these are general. This is in general in physics, where we can talk of temperature, we can talk of mass, we can talk of length, we can talk of time, we can talk of current, we can talk of voltage, we can talk of intensity of light. Okay?
Yes, teacher.
Are you getting me?
Yes,
Yes,
teacher.
those are basic quantities. But when we are looking at mechanics in particular, we look at only what we call the fundamental quantities, which are only 3D. Now, again, those those quantities that are derived into two. Again, I've talked of fundamental quantities and then derived quantities. And derived quantities are got from, just like the name suggests, derived quantities are got from they are got from what? Fundamental quantities when they're being expressed. Okay?
Yes.
Yes. Now, what are vector quantities? We said vector quantities these are physical quantities with both magnitude and direction. With both magnitude and direction. I think that one you still remember very well. Right?
Yes.
So what are they? For example, we have displacement, we have velocity, we have acceleration, we have force, we have weight, we have momentum, etc., etc., etc. Okay?
Yes.
Yes. For them, they have both magnitude and direction. Then we can also bring, just to bring a perspective in what we are looking at, we can also define scalar quantities. So scalar, these are physical quantities with only magnitude and has no direction. So when we are describing them, we just give them in terms of the magnitude or the size. We don't talk of their directions. And these are distance, speed, time, temperature, mass, and energy. You can talk of them on and on and on and on. There are very many. Okay?
Yes.
Yes. So now, when we look at vectors, now let's look at vector addition. In mathematics, when you are still in O level, you look at vector operation, vector algebra, vector what? Algebra, and also look at vector geometry. So the most important thing here is we're going to combine all those two concepts together as we move along. So we are going to look at vector algebra or vector operation. Then we are also going to look at vector what? Geometry. Okay? Yes. When we understand those two concepts, vector algebra, vector what? Algebra, and then vector what? Geometry. So like we have said, vector, they have both magnitude and direction, which means the most important thing here is the magnitude, the direction. Is the what? Is the direction. How do we deal with vectors? It's in vectors where we are saying that 2 plus 2 may not be equals to 4. Are you aware of that in vectors? Is where we are going to prove that 2 plus 2 may not be equals to 4. Why? Because we don't look at only the magnitude, we look at also the what? The direction. Okay? Are you together?
Yes.
Yes. Now, when you look at the first part, let's look at vector operation, which is vector addition. How do we add vectors? If you remember very well, how do you add vectors? We said you add vectors if the two quantities are moving in the same what? In the same what?
The same direction.
In the same direction. Hey, Stephen. Yes, Stephen? Okay, but I believe you are hearing us. So, vectors acting in the same line or in the same direction. If vectors are acting in the same direction, then their resultant along that direction is just the sum of the two vectors. It's just the sum of the two vectors. So here we are looking at basically velocity, we are looking at forces. Now when you look at that diagram there, we have two quantities, we have two forces acting in the same direction. Force A, which is 3 Newton, then B is what? Is 2 Newton. So when we talk of resultant members, resultant force, for example, here we are looking at resultant force. When we talk of resultant force is a single force acting on a body. Resultant force is a single force acting on a what? On a body. So now, we have two forces acting, 3 Newton and then 2 Newton, acting in the same direction. So we said we are just going to add the two vectors. So which means resultant is going to be A plus B, which is going to give us 5 what? Newton. And which direction are you going to give? Because we said it's a vector quantity. Which direction are you going to give? So the direction will be the what? The same. It is going to be acting. The resultant is also going to be acting in the same what? Direction. Are you together?
Yes.
Are you together?
Yes, teacher.
Yes. Then in Roman 2, if the two bodies, if the two vectors are acting, if the two quantities are acting in opposite direction to each other, then the resultant is going to be the difference of the two vectors. But the direction the direction is going to be in the one with the what? With the I what? Or the large quantity. Are you together, members?
Yes, teacher.
Members?
Yes, teacher.
Just let me connect my camera. I've deleted some few things. Okay?
Yes.
Let me connect my camera. So, we said if they're acting in opposite direction, we get the difference between the two quantities. We get the difference between the two quantities. We get the difference between the two quantities. And the direction of the resultant, will be in the what? In the what? In the one with the large or I what? Bigger quantity. So like you can see from there. So A minus B. Why are we saying A minus B? Is A minus B because A has a bigger, has I magnitude, has my magnitude of 3, then B has a small magnitude. So which means what? That's what we're saying. If it was B with I quantity or I magnitude, we are going to say B minus A. So the letter which is starting there is giving us the direction and which one has a big higher magnitude. Are you together? Are we together? So this one, if they're acting in the same direction, they're acting in horizontal direction, either vertically or horizontally. Vertically or what? Horizontally. Vertically or horizontally. Just give me a minute. Nalubega,
Yes, teacher.
are you able to see my screen? Are you able to see my screen?
Yes.
Even the writing space, are you seeing it?
Yes.
Huh?
Yes.
Okay, good. I've seen Brenda just come. Brenda? Brenda? Brenda and Sandra.
Yes, teacher.
What happened, Brenda? Yet yesterday we said exactly by 8:30 everyone must be in.
Sorry, teacher.
You people, okay. Even if I get annoyed, what will I do? You people, you are far away from me. What will I do? But let's just be responsible. Let's just be what? Responsible enough, okay?
Yes.
Nalobega,
Yes, teacher.
this is the thing we are looking at. These are the things we are looking at. Members, let me know if my writing is clear. I seeing it very well there. Okay. That was the first part. Now let's look at the second part. The second part. We are saying if there are two forces acting vertically or horizontally, if I have to, this is the body, these are two forces acting on a body. One is there, you can say this is 5 Newton. And this one is what? Is 10 Newton. This is acting what? It's acting, the forces are acting what? Horizontally. Forces are acting horizontally. We said, how do we get the resultant? So which means the resultant force FR is going to be, we look at the one with the high magnitude. So it means it's going to be 10 minus what? Minus 5. What? Newton. So therefore, our resultant force will be 5 what? Newton. Don't forget to put the direction because force is a vector quantity. Or we remember here we are looking at vectors. We know we said vectors have both magnitude and direction. So which means you're going to say 5 Newton in the direction. In the direction of what? Of what? Of 10? Of what? Of 10?
14 Newtons.
Of 10 Newton. Or you can give in terms of compass. You can give me in terms of compass. You can say, or 5 Newton, 5 direction, 5 Newton. What? Du what? This one is what? Du?
West.
Du what? Du west. You can give me in terms of that. Now, what about if they're acting vertically? If they're acting vertically, which means if they're acting vertically, it will be, this one is the body. Now I'm assuming this is 5 Newton. Then this one is what? 10 Newton. So still the procedure is still the same. So resultant force FR is equals to, so it's going to be 10 minus 5 Newton. So our FR will be equals to 5 Newton in the direction of 10 Newton. Or you can say or what? Du what? Du not. Or du what? Du not. Let me zoom in a bit. Good. Members, are we together?
Yes, teacher.
Yes. So that one is not important. This is just a thing you have already looked at. But we want to start from where we know, then we go to where we don't know. We start from known to unknown. So this is the thing you have already learned. What about when they are acting at angle? Let's look at B. When the forces are acting at a given angle to the horizontal, or the forces acting at an angle. Vectors acting at an angle. Vectors acting at an angle. So this is case number 2. This is case 2. Case 2. We say that when vectors, and when I talk of vectors, I'm referring to vector quantities members, can be velocity, can be force, can be weight, can be acceleration, can be momentum. Any vector, this is what I'm referring. Here I'm giving a general case. Okay? Are we together?
Yes.
So we are saying that when vectors or when forces acting on a body are inclined at an angle to each other, then a triangle of vectors is used to find a resultant. The resultant given by the line that completes the triangle. Let's look at this. Let's draw a vector diagram. We call it vector diagram. So if I have two forces, let me use forces acting at a given angle to each other. Let me say this one. This one, easy. Let me say easy. Which quantity is, let me say 3 Newton. Then this is 2 what? 2 what? Newton. So we are going to resolve these forces. We are going to resolve them in 2 components. Resolve the forces. Resolve the forces in two components. Into 2 components. That is vertically. And what? And horizontally. Now here you must remember your trigonometry very well. You must remember our trigonometry very well. So you have to recall trigonometry. Trigonometric ratios. What are those trigonometric ratios? We have, just remember what? Soccer what? Members, we remember what? The SOHCAHTOA. What does this one mean? This is mnemonic. It's mnemonic in nature because all these have their meaning. S is standing for sine. Then this one is standing for what? Cosine. This one is standing for tangent. But sine, which we just write as sine of any angle theta, is given as opposite over hypotenuse. Then cos of any angle theta is given by adjacent over hypotenuse. Then tangent of any angle theta is given as opposite over adjacent. These are the things you must remember. Then apart from that, this one is only applicable. SOHCAHTOA is only applicable for right angle triangle. That's the first thing you must remember. SOHCAHTOA is only applicable for right angle triangle. What about other triangles? Which is not, take for example, isosceles, isosceles triangle, equilateral triangle. Which formula do we use to apply for them? If it's not, then we must remember the sine rule, or the cosine. The cosine what? The cosine rule. When we are resolving forces, when we are resolving vectors. We know that sine is given by A over sine of angle A equals to B, side B, divided by sine of angle B equals to C, divided by sine of angle C. That is sine rule. Then cosine rule is given by, if I have A squared is equals to B squared plus C squared minus 2 twice the 2 side BC cos of the angle A. So these are the things we are going to look at. We are going to be really quick just on them, which I believe is clear from our mathematics. If you have forgotten, I will keep on reminding you as we move along. Are we together, my dear students?
Yes.
Are we together?
Yes, teacher.
All right. So Those are the things we have to put into our mind when we are looking at vector. Because in resolution of forces, what the only thing we need is to form a complete triangle. Is to form a complete what? Triangle. So in the process of completing a triangle, if you form a right angle triangle, then you must apply this. If you form a right in another triangle, which is just a triangle but not a right angle triangle, then you must apply either cosine rule or cosine rule for you to resolve or to find the resultant. Now, when you are completing the triangle, what you are going to complete is what is going to form the what? The resultant. And for those who have come late, I said resultant. Resultant means is a single force. If I'm talking about in terms of forces, resultant force is a single force. Resultant force, definition. Resultant force is a single force. Is a single force acting on a what? On a what? On a body. Resultant force is a single force acting on a body. So, but how do we get resultant forces for vectors which are acting at an angle, like I was giving here? Let's come back to this. Now, when you look at this, how many forces do you have here, members? How many forces do you have here? Now, it's acting at an angle theta. Let's say it's acting at that angle theta. To the horizontal, this is y, this is it, this one is what? Is x. Now, when we have angles which are acting to the horizontal, this angle is theta to the horizontal. So which means if I form a simple right angle triangle here, there, this angle is 90. So this one is going to present for me y, this is going to present for me what? X. Horizontally, then vertically. But I want to resolve this one. When you look at this one is already, this 2 Newton is already what? In a horizontal component. Is already in a horizontal component. So which means we shall have resolving, that's a resolve vertically. So which means that one will give us F what? Fy. Will give us Fy. Now, when you look at this one, members, let's come back to this. Well, I want to find this y. I want to find this one. Which trigonometric ratio should I use? This is it. This is it. The 3 Newton. This is 3 Newton, which is going to give us the hypotenuse. Then the y is going to give us the what? The opposite to this angle. It is opposite to this angle. So which trigonometric ratio is that? Opposite hypotenuse. That is it. Opposite hypotenuse. Which trigonometric ratio is that?
Sine.
So which means this one would be, so we shall have 3 sine what? Sine theta. Is there another component which is acting upward? No. There's no component which is acting upward. So which means that is what? That is 1. What about horizontally? Members, when you look at horizontally, we have two. We have this, which is already, this one is already, is already in a horizontal component, is already in the x component. So the only thing we have to do is just to resolve to get the horizontal component of this 3 Newton. So we have hypotenuse adjacent. Hypotenuse adjacent, which one is that? That one is what? That is cosine, no, sir? So which means I will have our fx is going to be equal to the 2 Newton, which is already horizontally, plus 3 cos of what? Cos of theta. Cos of what? Cos of theta. So that's how we get. Now, if you want to find, but this is not yet resultant force, members. This one we have just got the components. We have got the vertical component and the horizontal component. Now, it depends on the direction of these forces. It depends. If this one is a positive, we have seen this is positive, even this one is what? Positive. So which means we can come out with our triangle now. Which is in simple term. The triangle we are going to draw depends on the direction of the components we have got. Depends on the direction of the components we have got. Depends on the direction of the component we have got. So this one is there, this one is there. Because the direction, the arrow is given the direction. So now, where will be our resultant? We said completing the triangle, completing this triangle is what gives us the resultant. Completing the triangle. When we complete this triangle like this, just completing it like this, like that. That will give us the resultant. Which direction will it be? Which direction? We can put it anywhere. I can put it here. I can put it that one. Okay? I can put that is my direction. Or if you don't want to do that, what you can do, you can just put it like this. You can put it like this. I'm giving different options. We can draw our resultant to be here like this. Like this. Then you complete the triangle here. You complete this triangle here. Where will our direction be? The direction will be here. Are you seeing that? Members, are you seeing that? So this one is still, this is it, Fy, this is Fx. This is it, this still remain Fx, then this is our Fy. Members, have you seen the difference? Now, when you look at this, now the resultant I want to find is this one, this is my Fr. That's the resultant I want to find. So which means the resultant Fr will be equals to, when you look at this one, this is a right angle triangle. So which means it is a right angle triangle, and I know this, I want to find this. So which means I must apply Pythagoras what? Here you must apply Pythagoras what? Theorem. Which is it? So it's going to be Fx squared plus Fy squared under what? A square root. Under what? A square root. Under what? A square root. Now, after doing that, remember this resultant is a vector. It's still a vector, which means it must also have a direction. It must also have it what? Direction. How are we going to find the direction? The direction is now this angle theta here. You can see clearly from there. Either I'm using this or I'm using this. Still must give me the same thing. The angle must always be to the horizontal. If it's not to the horizontal, then it must be to the vertical. Or you can give it in terms of bearing. You can give it in terms of bearing. But when you're giving in terms of bearing, you must be familiar with compass bearing. You must be familiar with compass bearing so that you can get the good thing. So direction. I want to find this angle, member. Which trigonometric ratio should I use? Here I must remember the SOHCAHTOA. I must remember. So I know this adjacent, I know the opposite. Adjacent opposite, that is a tan. So which means tan of this angle theta must be, which is going to be Fy over F what? Over Fx. So which means theta will be equals to the arctan. The arctan of Fy over F what? Over Fx. As simple as that. Members. Are we together? Are we together?
Yes, teacher.
Brenda?
Yes, teacher.
Have you got it right, Brenda? Sandra?
Yes, teacher.
Sandra?
Yes, teacher.
You have got it?
Yes.
What about Stephen? Stephen, are we together? Stephen? Stephen is not talking. I think there's a problem with his microphone. If you cannot say please, then you can text me. You can send a text on the chat, okay? So that we move together. Now, what we have done here, this one is when the forces are the angle. They're acting at an angle to the horizontal. What about if they're acting to the vertical? What about if they're acting to the vertical? I may have this. Let me sketch this. I may have this. This is my y. This is my x. Then there's a force here. Then there's a force there. Then there's a force there. Let me say force F. And this time is acting to vertical. The angle here is theta. The angle is there, what? Theta. Remember, the angle there is what? Theta. So how are you going to resolve the forces? How are you going to resolve this force? You find that this time, now what we are going to have, you're still going to form a triangle there. Just put a triangle. You form a triangle up there. That's a simple one. You can have a simple sketch. What is important here, we must form a triangle. We must form a triangle. So this one is going to give me the vertical component of this. Then this is going to present the fx. So you see that there's this triangle now, this one you're going to form. You find out this one is going to be f cos. Are you seeing that, members? This is going to be what? The vertical component is going to be f cos. Then the horizontal is going to be f what? F what? F sine theta. So, what does that one mean? In general, when vectors are inclined at an angle, to the horizontal, comma, its components are given by, so you find that fy will be equals to f sine theta, fx will be f cos theta. That is number one. Number two, if it's to the vertical, inclined at an angle to the vertical. To the what? To the vertical. So you find that we shall have fy will be f cos what? Theta. Then fx would be f sine what? Sine theta. Are we together, members? Are we together? Yes? Please respond to me, please. Respond to me, please. I want us to move together.
So we are together.
Okay, very good. So that part is clear. That's what we are deriving there. We have got it. So we said when a vector is inclined at an angle to the horizontal, then along the horizontal, the component of the vector is cos. Along vertical is it sine. That's what we have summarized there. So when it's inclined to the vertical, then its component will be that. Then the resultant is that. Direction is this. So now let's look at this example here. They're saying three forces are applied to a point as shown below. Then another thing you must also note. The vectors must be acting at a common point. At a common what? Members, at a common what? At a common point. So that's when you can apply this one we are looking at. So let's look at that example number one. Example number one. Can you draw it yours? Can you draw yours, please? So this is our y. We are using dotted because it is imaginary. It's imaginary, which means there's no forces acting in that. Then this one, we have x. When we have 14 Newton. This is 8 Newton. then this is 6 Newton. The angle, this is 45 degrees, this is 45 degrees as well. Then there's that common point O. They want us to find the resultant. Find the components, resolve the components. Members? The question wants us to find the what? The component. Tomorrow they may not ask even in principle, they'll just say find the resultant. So the more
Yes, teacher.
before you get the resultant, you must first get the what? The component. Analyze the diagram. Analyze the first diagram. When you look at this one, the angle of inclination, all are inclined to what? All are inclined? Inclined to the what? To the what? To the?
Zero.
The horizontal, which means vertical component, vertical will be, vertical must be what? Must be sine what? Sine theta. Then horizontal must be cos what? Cos what?
Cos theta.
Cos theta. Now, if you remember your Cartesian plane very well, if you remember the Cartesian plane very well, if you remember the Cartesian plane, let me have a simple sketch here. Let me have a simple sketch of the Cartesian plane. This is x-axis. This is x what? Axis. Remember, we said this point, I think from here going this side. All these are x values. These are x what? Values. Here x is positive, x is also what? Positive. What about this side? X is negative, x is also negative. Members, have you seen that? When you come to y, all this side is positive, even this side is negative. Members, are we together? Take note of that. Take note of that. Now let's start resolving. So you start saying resolving the forces, vertically and what? And horizontally. So vertically, we'll have our Fy, which is equals to, what will be our Fy, members? What will be our Fy? We have what? 6? 6 what? 6 sine of what? 40? 45. Now, when you look at this one, the 8 Newton is in the negative side of y. So which means it must be what? Must be what? Minus 8. 8 sine 45 degrees. So shall have Fy equals to, can you enter those details in the calculator? Just put it once. So open a bracket. 6 sine of 45 minus 8 sine of 45. Close that bracket. So you find that you get negative. It's negative 1.4. 1.4. 1.4. 2. What? Newton. This is to 4 dps. The reason why I'm doing that so that we minimize on the errors. So the direction is negative. So you know where negative y is. Horizontally, let's look at horizontally. Horizontally, we shall have fx equals to, the first one is 14. 14 is already horizontally, so that one is just say 14. Now, when you look at this one, remember, when you look at this one, they're all in the negative side of x. They're in the negative side of what? Of x. So which means it's going to be minus 6 cos of 45 degrees minus 8 cos of 45 degrees. So what do we get? We shall have our fx equals to, let's put everything in the calculator, 14 minus 6 cos of 45 minus 8 cos of 45. What do we get? we get 4.1005 Newton. Members, are we together? So now, the first question, part A was asking for the component, which we have got it. So part B is asking now for the resultant force. They want us to find the resultant force. Resultant force. Before you get the resultant, just have a simple sketch.